Hello everyone, welcome to Maths Easy again. Here is the second example about Kirchhoff's law question. Now I've already done one question earlier and I did it in a lot of detail. So I'm just trying to do this a little bit quicker than that with slightly less explanation because all the details are fully given in the previous one to save time and to make it easier, right? But I'm still going to walk through all the steps. So in a circuit like this, we don't know the current in any of the branches, so we just need to start it by marking the current. Now, normally we start to the current from the biggest power supply. In this case, I've got two of them and this is large, so let's mark it like that. Capital I, capital I, capital I. Now, if you've seen the previous video and tried that question yourself, maybe you can stop the video at this point and draw the diagram and then give it a try yourself. Now make sure when you draw the circuit diagrams, always draw sufficiently big diagrams so you can mark all the current and everything without making it too crowded. Right. Now, here's a split of current. So let's say the lowercase I here goes here. I take away I goes to this one. I minus I comes here. Now lowercase I go through this and here. Now lowercase I add I minus I again gives you capital I. Now I'm going to label it just capital A is missing here for some reason. Okay, A, B, C, D, E, F, A. Now I'm going to write Kirchhoff's second law to a loop. So let's write it to A, B, E, F, I. Okay. E, F, A, sigma EMF is equal to sigma PD. So let's do the walk. So I'm going to walk from A, no power supply, no power supply. Oh, there is one here. But can you see, I'm going from B to E, but this power supply is against my motion. So it has to be -3. And I'm going to continue the motion, continue the walk. No power supply, no power supply. This one helps me. Now we are going to do the walk again, starting from A and to find any IR products. So let's go it from here. Okay, here's the first one. 19 capital I. So let's write that. 19 capital I. Let's continue the walk. 4 lowercase I. And let's continue the walk. I'm only looking for resistors and IR products. There's nothing else. So I can simplify this a little further. 8 take away 3 is 5 is equal to 19 capital I plus 4 lowercase I. That is my first equation. Now I need to do it for another one. I can do it for the big one or the one on the right hand side. It really doesn't matter. So let's take one of them. Let's take the big one. So I'm going from A to around it back to A. So sigma EMF is equal to sigma PD. Now let's do the walk. So I'm first going to do one walk around the whole path, picking up any EMFs. So no EMFs to start with. No EMFs here, nothing. There's no EMFs, no EMFs, no EMFs. Oh, there's only one, and that's going in the way I'm going. So that's 8. So it's a very simple one. 8 is equal to sigma PD. Now let's do another walk. Starting from A, I got 19 capital I plus, I'm just walking here, 3 I minus I, and that's it. So let's write this down. So 8 is equal to 19 and 3, 22 capital I, take away 3 lowercase I. Now, I got two simultaneous equations and I'm just going to solve them. Okay, so I've done the calculation here, the simultaneous equation simplification. I kind of talked through how to do this in a simpler way in a previous video. If you want, have a look at that one. Now, the value of lowercase I is negative 0.29 amps, showing that it goes in the opposite way. So it's not going in like down from B to E, it's rather going from E to B. And the value of capital I is 0.32. So the question is to find the current through each each power supply. So the answers are capital I 0.32 and lowercase I negative 0.29. Now I'm going to again get a small diagram of the same circuit and show you how the current works. Now you don't really need this part for this particular question because the question was only about finding the current through the batteries. So the value of capital I is 0.32. So 0.32 amps go like that, and 0.32 comes to this point. Now, lowercase I is negative 0.29, so I know it's the other way. So the current this way is 0.29. Now, 0.3 to add 0.29 is the current in the branch BC. So a current of 0.61 amps go from B to C, down this one, this way, and 0.61 amps. Now from that, 0.29 amps go that way, take them away, and you can clearly see 0.32 amps go that way. So the whole circuit works in terms of Kirchhoff's first law as well as the second law. That's really it.